Hello, my name is José Ramón Martinez. Welcome all to the webinar about Simware 4.0. The agenda for this webinar will be: first, we will talk about the capacities of Simware. Why is Simware necessary for you? What can Simware do for you? Then we will talk about the elements of Simware, the different tools, the different applications that make Simware. At the end, we will make a summary of the advantages of using Simware. The total time will be 45 minutes with 15 minutes to questions. First, capacities of Simware. Simware is a distributed real-time simulation middleware. Indeed, it's a simulation framework for real-time distribution, for real-time simulation. It allows real-time communication, in this case DDS communications, combined with HLA data model. It allows interoperation between DDS and different HLA vendors. For example, HLA pitch, HLA MAC. Also between different vendors between them. For example, you can have one federation in HLA pitch and another federation in HLA MAC. Also, it's a full simulation framework for development and deployment. Finally, is HLA compliant. Is HLA compliant in more than one way. One way is that we use rules of HLA and data model of HLA. The other is that we have a tool into Simware, into the Simware framework, that is a HLA RTI that complies with HLA 1516. But which are the features? What is the added value of Simware? With Simware, you can have the best data model available, that is an HLA style data model, and a real HLA data model with objects, with interactions, using a phone if you like, with real-time communication. You have an HLA data model running in a real-time data bus, because with DDS you can have real-time features, real-time communication, even hard real-time. Also, you have all the quality of services that DDS provides. You can have a very easy, a very real data modeling. There is, you can model your data with a lot of fidelity. You can use an HLA style data modeling. You can even put a phone model directly, straight away into our tools, and we will make for you a library that uses that data model for publishing and subscribing. And you don't need to code anything. This data model you can edit, you can save, you can reuse, you can change, because it's only related to data. The data types are going to be HLA data types. The API we provide is very simple. With just 2 lines of code, you can make a simulation and you can join it. And these 2 lines are the same for HLA or DDS. You can join a federation in HLA, or you can make a simulation in DDS with these 2 lines, just 2 lines. You only have to change one string, that is the transport type. You can choose between DDS Open Splice, that is a brand of DDS, HLA Mac, HLA Pitch, etc. Also, you can add quality of services to your entities with this API. With Simware, you can make your simulation models reusable. You can reuse your simulation models. The simulation models can be edited, changed, and reused. If you have a new simulator, you can reuse the model you have for another simulation. You don't need to create it again. You can reuse them, and you can put them into the simulation just changing one configuration file. You don't need to recompile anything. With this approach, your simulation models are now assets. With Simware, the gateways are data bridges, are only know about data, only edit data, only change data. You can edit your gateways, you can change your gateways, you can modify your gateways, and your gateways only talk about data. There are no tricks here. You only have to choose the data you want to communicate, and we will create an application for you. You don't have to code anything. And here you can join the simulation. Simware is a full simulation framework. One side has tools for developing all the elements of the simulation. Again, you don't need to code anything if you want. But if you want to code anything, we have an API we provide to code anything you want. And also, we have applications for the runtime. Applications for running the simulation, for managing the simulation, for controlling the simulation. So we have a full framework and a full architecture. With Simware, you can command the simulation runtime. Everything is data. We provide you with a scheduler for controlling the simulation time and the state machine. And we provide you with a simple console for controlling the simulation. You only have to run this console, and here you can control the simulation, control the instance of the simulation, load and save the scenarios, etc. With Simware, your simulation elements, for example, your plane, became instance. The elements can be added, modified, or deleted during the simulation runtime. You don't need to stop your simulation for adding a new element or for changing any parameter of an existing element. Each object, each element can be instantiated multiple times. You can change the parameters, or even you can change the parameters during the simulation. So your plane can become, during the simulation, one kind of plane, another kind of plane, or even a paper plane. You don't need to code anything. But of course, if you want to code, we provide you with an API, a very simple API for coding. You just have to add two includes to your simulation, to your code. One is the data model you have made, and the other is the API. So with that, you can make a simulation and start sending and publishing and subscribing things. If you need another thing, for example a visual, you can add it over it. Interoperability. Simware makes interoperability very easy. You can have an HLA of Mac joined with an HLA of Pitch, join with a simulator over DDS, and all of them in the same simulation. And all the data, all the gateways are data bridges. Here we have some use scenarios. Of course, these scenarios are typical uses of Simware, but you don't have to do that, of course. You can do what you want, but these are typical uses of Simware. The first one is making a standalone simple simulator. Here you have your data, you model your data, you put this data HLA style in our tool, and we will make for you a library with this data model. Then with NcWare SIM, you can add your own simulation models. For example, you have your simulation models that are legacy, that are made for another simulator. Now here you can wrap this with our API and with our library of data model, and then you can put that into our scheduler. So now you can command the simulation with the scheduler and the simulation engines. On the other side, you can make your own tools using our API and using our data model. Here you will have to code, of course, in this scenario. Another scenario, okay, you don't want to code anything. You have your model, you put your model into data model, then using one tool of Simware with MATLAB Simulink, you create your logic, and we will wrap this logic with the data model you have choose, so that you can put this library, because at the end we will compile for you a library, this library into the simulation. And now you only have to decide the frequency and where these models will be loaded. On the other side, we have some tools for commanding this simulation. Here you don't have to code anything, and you can have a full simulation with all the logic you want, with all the models you need. Even this simulation can be distributed anywhere, in any number of nodes. Finally, full joint simulation is more or less the same, but in this case you have an existing HLA federation. For example, you have an HLA federation in Mac. Here you only have to make a data bridge. With our tools you can make a data bridge, just deciding which data are going to be communicating. And that's all. We will make the library for you, and this library can be put into the same simulation and controlled into the same simulation. So here you can make a full joint simulation, not knowing anything about the code, not coding anything. Now we will talk about the components of Simware. In Simware we have two kinds of elements. We have all the tools you need for building simulators. These simulators can be HLA, can be DDS, or can be mixed simulators DDS HLA. And we have all the applications you need for executing and managing your simulation. Now, here we have some names of tools. For creating the data model, the tool is the modeler tool. With modeler, you can model every data you need in HLA style. Then we have the GPGUI for defining your instance. You have your elements in the simulation, you have your object, you have your plane. But now you want to do two things. First, establish the initial values in the simulation, which is the altitude of the exercise, for example. Second, establish the limits of the instance. For example, we have a plane. The plane has a parameter, this is the altitude. The altitude is between, with this tool you can define this interval between 0 and 1000 meters, for example. Then, running the simulation, you will decide which is the value you are going to use, the real value. But here you define the limits. Another tool is for modeling your simulation models, that is Developer. This tool is integrated into MATLAB Simulink. You model your elements in MATLAB Simulink, and we make a library for you that is this data model, and you can use it. Another tool is PowerLink for creating and managing your data breaches. You can have your data breaches, you can save, you can recover, you can modify your data breaches, and everything is related with data. And finally, in the core is NcWare SIM. NcWare SIM is the API for making your own elements of simulation. And we have applications for managing simulations. We have an application for scheduling, for controlling the clock of the simulation and the data model, that is called Scheduler. We have a tool for loading the simulation models, that is, the name is Simulation Engine. And we have the ACS for running the simulation, for loading and saving the scenarios, and for managing the instance of the simulation. Finally, we have the gateways, that are the data bridges for communicating between HLA vendors, HLA federations, and DDS simulators. These gateways can be between HLA and HLA, for example, between HLA of pitch and mag, HLA and DDS, and in the third quarter will be with this. So we will have this with HLA, this with DDS, etc. Now we are going to see Simware going tool by tool. The first one is the modeler. The modeler is the tool for modeling your data. You can start from an HLA data model, from a phone, or you can start from scratch. But the thing here is that the data model is HLA style. You have objects, you have interactions, you have HLA data types. The models here can be saved, can be modified, can be loaded, can be managed. And this tool will generate the data library automatically, so you don't have to code anything. Then we have eHost. eHost is for simulation management. eHost is really two tools. One of these is the scheduler. The scheduler is a tool for controlling the real-time clock and the state machine. Then we have simulation engines. These simulation engines are the tools that manage the modules in each node. Here, the thing is that the scheduler and the simulation engines are decoupled. That is, the scheduler doesn't know in which node are the simulation engines and how many simulation engines will be. And simulation engines don't know where is the scheduler. At the beginning, the scheduler starts and loads the configuration file. Then it waits until some simulation engines join the simulation and ask for this information. Ask which are the modules I have to load, which is the name of these modules, which is the frequency of the simulation we are going to run. And everything is outside in a configuration file. You only have to change this configuration file to change which module is going to be loaded in which simulation engine. Another element is the NcWare SIM. The NcWare SIM is the API. With this API, you can create your own simulations elements. For creating a simulator, you only need 2 lines of code. You only have to change the transport type to change from DDS to HLA, to HLA MAC, HLA pitch, etc. Here we have some examples of creating a publisher or a subscriber. Another tool is SIM Developer. With SIM Developer, you can create your simulation models. This tool is based on MATLAB Simulink. With it, what you do is, okay, you model your models into MATLAB, and then we will wrap it with the data model you have chose at the beginning. So now we will make for you a library, and you can put this library into the simulation. You don't need any programmation skill here. You only need to know about building simulation models. Of course, the simulation models can be reused, edit, change, etc. We have PowerLink. PowerLink is a tool for making the data bridges. It's a tool that have 2 parts. One is for one model, the other is for another model. And you have to choose which elements you want to communicate. That's all. All is data. We will make the library for you here. You don't need any programming skills. You can choose, for example, in one side HLA of MAC or HLA of pitch or DDS, and in the other, for example, you can choose DDS or this, whatever. And these data bridges can be reused, can be modified, edited, etc. Then we have our ARM, Asset Repository Manager. Asset Repository Manager is a web-based element that allows you to catalog, to have into a database your simulation assets. You can have your own collection of simulation assets. You can put some attributes to them, and you can store them in a database. With this tool, you can manage your asset of simulation elements. Another tool is GPGUI. GPGUI is a generator of panels. You have your objects, for example, you have your plane, but now you want to put the initial values of this plane that will be into the simulation. With this tool, you can decide the initial values of this. Another thing you can do here is you can decide the interval of values, of valid values you have for any attribute. For example, your plane has an altitude, okay, but now you can decide with this tool that the altitude can be between 0 and 1000 meters. Then, running the simulation, you will make your plane in any value in this interval. Finally, here we have ACS. ACS is the tool that allows you 3 things. First, can load and save any simulation scenario. This tool doesn't know which are the elements of the simulation. When this tool starts, it asks to the scheduler which are the elements in the simulation. Then, with these elements, you can have scenarios. You can have 2 planes and a ship. You can have anything. Also, you can manage the state machine here. You can init, execute, pause, finish, etc. And finally, you can make the instance of simulation here. You can create new elements dynamically. That is during the runtime. You don't need to stop the simulation. You can add anything here. Or you can modify the existing elements in the simulation. You can change any parameter. You can change the altitude, you can change whatever. You don't need to stop the simulation. You change, for example, the altitude, you click on update, and then the altitude changes into any element that is running the simulation dynamically. The last tool is the Simware RTI. It's an RTI for putting together HLA and DDS without any data breach. One side is HLA 1516 and the other side is DDS. You have 4 services of HLA here that are the services required for virtual and live simulations. And at the other side you have DDS. So here you don't need any data breach. Finally, with Simware, you can have a data-centric approach to simulation. Everything can be related to data. You don't have to care about architecture or any element. All the architecture, all the design can be data-centric. Because our tools, for example, Modeler, speaks about data. The data links, the data gateways, the PowerLink tool speaks with data. And every tool uses data. Even the control, the data control, are data that can be modified. Another thing is that with Simware, you can make your simulation models become assets. You can have your own family of models. You can have your own collection of models. You don't need to start from scratch when making a new simulation, a new simulator with new models. You can reuse your plane from one simulation to another. You can edit this plane into MATLAB. You can change anything. You can change the parameters. You can change the values, but you can reuse them. You can have your own collection. And that's all. Thank you.